Welcome to Chapter 3 of Building Production Level E-Commerce UI Agent and E-Commerce Purchase Agents. We are going to use again Reward Engineering and UI Agents. This is Chapter 3 and we will create a basic website using UI Agent with a playwright, and we will also train a small PPO agent and a basic GRPO agent. In Chapter 4, we are going to use multiple A100 GPUs to train complex e-commerce UI with 100 plus elements, and also we will use many versions of UI templates across different CSS and JavaScript versions. We will use multi-step flows and real user data using PPO and GRPO. That fourth chapter AI agent will be successfully completing purchase flow, search flow across multiple dimensions and types of website and of various designs and templates. But before doing a complex work, we need to really explain how simple things work. This chapter 3 will be a better stepstone to chapter 4. We will initially create a UI gem. This time we are going to use Playwright to do a UI gem. UI gem can be of anything. In this video we are going to use a browser and we are going to render a small sign-in page. This is our UI playground. This is where our AI agent is going to play, and we are going to use Playwright to render this HTML, which contains one username, one password, and one remember me checkbox and the sign button. So the agent goal is going to be like click username and type some username, probably agent, click password and then type some password, which it is going to be agent again, and then click remember me before clicking the sign button. So if the particular step order or if the necessary fields are like filled already and then the agent is like trying to sign in, we are going to reward the agent with 2.0. If it fails, or if it is clicking sign in button in the first step or before filling username, password or remember me, we are going to penalize the agent with -5. To do some randomization and also to make sure the number of steps the agent takes to achieve the goal is as minimum as possible, for every step agent take, for every action agent take, we will introduce a small minor penalty -0.05, so that the agent will also make sure that it takes less number of steps to achieve the goal, and also it doesn't do the same action again and again. Even if it does the same action, it will get different rewards different time. So that's how we are going to do it. So we need a UI gem, right? We need a playground so that AI can work. So that's why we are going to use Playwright, and we are going to use headless for PPO, and I want to show you guys how GRPO works. So most likely I'm going to remove this headless for GRPO, which will launch multiple browsers at the same time, and this is the initialization part, and then we will set the content of self.html, which means we are rendering a page so that AI can start work, agent can start work. The state of the whole page, if you look, there is only 3 inputs: username, password and remember me. So basically only 3 inputs, so there is only 3 states, right? If username has some value, we will return username state as 1. If password has some value, password as 1. If checked is already checked, we will return checked as 1, and then we will return dummy 0.0, so that we also consider the sign in button. So basically every time there will be 4 states. For example, sample states of this game will be, sample state might be only username filled, okay, only username filled. This will be like one for username field and other fields are 0. If only password is filled, the other 3 things will be 0. If 3 things are filled, right, if username and password are filled, the state will be 1100. So you get the point, right? So basically state is a 4 integer variable which will be storing what is the current state of this three variable, and then sign in button, we are just adding sign in button to make sure it is complete. So in any environment, Playwright or UI gym, web gym, or any sort of gymnasium kind of environments, we need AI agent to select one of the possible actions. Here one of the possible action is it can enter a username, it can actually enter a password, agent can also check the checkbox, that is one action, and it also can click the sign button. So there are 4 possible valid action in this whole HTML. If the HTML is different, if you consider Amazon sign-in page, that might be totally different. There might be hundreds of different possible combinations and 100 buttons, links, anything, buttons, links, anything that can be clickable icon, clickable and enter input items, right? So basically here only 4 actions are possible, so that's our action space. So whenever AI chooses an agent chooses an action, our environment, here it is a Playwright environment, you might have a gymnasium environment, so environment has to take the action, perform the action, and also check if there is any opponent, give the opponent opportunity to play the game, right? That's for a random usual game, and once the opponent plays the game, it actually, or n number of opponents should play the game, right? So n number of opponents will be given opportunity to play the game, and then current environment setup of this agent also will be updated, right? Based on the action taken by agent and also competitors, current state will be modified, so the environment state will be kept updated. So that's what the async definition step is going to be. So just before we go, I am using async and await because Playwright is async and we need as Playwright to be async. We are going to call this in async mode. We are going to use everything in this example specifically. We are going to use everything in a async mode. That's why you are seeing the async definition for the functions and await definition for the calls. So to do a step, so basically when somebody does a step, right, we need to check what is the action taken by the agent, and based on that we need to perform that action. The environment usually performs the action. Only agent decides what is action, and environment is the one who performs the action. Here environment fills username as agent, but we can actually pass anything based on some random characteristics. Also we can pass some different usernames, or based on predefined workflows we can take this as a parameter. So if the agent is choosing action 0, we will fill username. If the agent is choosing action 1, environment will fill password. If the agent is choosing action 2, environment will check the box. If agent is saying okay, I am going to sign in, we will initially environment will check what is the value of username, what is the value of the password field, and whether the checkbox is checked. Only if all 3 are good, we will say okay agent, you are done, you did a good job, and we will reward the agent. So and then like if the agent is clicking sign in but any one of this is not going through, which means all the states, so all the states should be 1. If all the states are 1, we are good, right? If all the states are not 1, we will return reward as minus 0.5, penalizing agent because for clicking sign in button, right, button without filling username or password and the checkbox, right, checkbox. So we are going to send a penalty for this run. So once the agent clicks sign in, which means the agent is saying I am done with this whole setup, I am ready to move on to the next run. So now we are saying you didn't complete username checkbox or something, so basically I am going to penalize you. If this is the only thing which returns a reward, otherwise we will send the new state to the caller, right? We will perform the action of the agent and then send the new state. Just one more thing to note here is every time agent calls, it gets a negative reward. The negative reward, I will come back to this things later. The negative reward is the reason the reason for negative reward is to make sure agents also complete this in as less number of steps as possible. So let's say agent took like 100 steps to complete to click the sign in button, after to complete these three and click the sign in button, which means it will get like -5 our reward. And even if it is getting 2 here plus 2 here, the final reward will be +2 -5, which will be -3. Basically we are going to still penalize agent even after completing all the task, because it took so much time, right? So that is the reason we are going to give negative reward for the agent which miss on every single transaction. Which brings us to the next thing called PPO policy. Initially what we did till now is we defined what is a gym, what is our environment, and what are all the state of the environment, right? What are based on the action space, and how the environment will react for any of the action taken by the agent. Now we are going to define what is a PPO. A PPO based on the algorithm is a very simple neural network. Any simple neural network will take the input and then will project it to at least one hidden neurons. And here in the PPO there are two different networks. One is actor network, another is a critic network. In this we are going to take four inputs. Four inputs are here. Four is equal to the state, right? We have one input, 2 input, 3 input, 4 input. So we are going to take 4 action space. Out of the 4, actor has to choose one possible action, right? Actor is the one who is choosing the right action or wrong action, whatever the action it is going to choose one of the 4. In this case it is only 4 if you assume we are going to train and have a e-commerce agent, and the agent has to pick one of the available action in the action space, which might be like 1 out of 1500 or like whatever, how many minimum of 200 actions per possible in any of the space. Even if you open an Amazon e-commerce website, you will see like so many places where the agent can click and go wrong, right? It cannot, and also there are multiple text boxes where agent can go, and if an agent clicks a wrong box or a wrong product, it might wrong link, it will lead to completely different flow, right? So basically the actor is the one which chooses the correct action or any action. Initially it is any action. After 20-50 episodes, based on the training and the code, actor will become very confident in choosing the right action to reach the goal with minimum number of steps. We will see that. So this is going to be a simple neural network converter. It takes the 64 hidden state neurons and then convert into 4 log probabilities. So the output of the actor is going to be probabilities distribution, which you can think distribution as somewhat, it will return a distribution something like this, which will say 40% I am confident I'm going to, we need to take first action, which is fill username. 50% I am confident, actor is confident that next best action is password, and 5% we need to check the box, and 5% we need to click the button. So this is the distribution of probabilities that actor emits on every single call. So whenever you call this agent brain, which is a PPO module, it will take 4 states, current states. The current state might be like current state might be anything, right? It can be 1010. Basically this means current state is agent already filled the password, and also agent also clicked the checkbox. Again, based on this we are going. So based on this, the actor is going to emit distribution probabilities, which might be different or it might be same based on the actor's knowledge and where we are at the PPO training stage. It might not be matured, or the actor might be already matured and know what to do at any point of time. Basically, it emits 4 different values, which will be telling what is the best action or next action that is going to be proposed by the actor. Which brings us to the next network called critic network. Critic network, you can think as critic network as a judge network, which will take again the same 64 space and tell what is the reward. It guesses what will be the reward for the current state. So it might be wildly saying we will get a -5 reward, 2 plus 1.9 reward. So basically it can do anything. Initially it will be very erratic, and once we keep learning and we pass the critic loss and actor loss, we will do a normal back propagation just like any other small neural network. The critic will start learning, and then it will direct the actor and also the whole network towards the correct path. So basically this is a judge path. Only just to do one more thing to make sure we understand, the critic is only relative to PPO policy. If we are going to do any other policy like a GRPO or anything else like RLHF, the critic might not be there. We will substitute with something else. The whole network might have a different structure, but critic and actor are for only PPO. So forward network is very simple. You push the state into 64 into the shared thing and get it reload and find the stop to max of actor and critic, right? And with this will be returning, this whole statement will be returning two different things. Initially the first parameter will return four probabilities, and critic will return a single value of, it might be -5 or 1.9 or whatever the reward that it thinks. So we will also compute the reward. How do we compute reward returns? Is we are going to use a parameter called gamma. So whenever we have a reward for the current state, which will be like a 2 or something, when the reward, assume that we are getting a reward of 2 because the agent is complete, right? Agent actually clicked sign in, and before clicking sign in, it actually I'll show you guys. I think I already returned this. Assume that in step 4 agent clicked sign in, so that agent got 2 reward. Step 1 it clicked the enter username, it got a -0.05 reward, right? And it cumulative till now is -0.05. Step 2 it agent chooses to enter password, -0.5. Every step will have get -0.5 for sure, and cumulative will be -0.10. And step 3, the state here when it action chosen was to click the checkbox. While clicking the checkbox, the state was it has already entered username and it also already entered password. So basically 1100 was the state. When after it clicks the checkbox, the whole action, even though action was clicking checkbox, we don't end the game until the sign in button is clicked. So basically even then it gets a reward of -0.5. But the cumulative here is like -0.05, cumulative is -0.015, 10 and we are keep adding that -0.05 as a cumulative reward. But when the agent decides to click sign in button, it will get 2. It will get 2, and the state, if the state is 1,1,1,0, which means it already have pasted the username, it already have pasted the password, and also it has clicked the checkbox. Cumulative is 1.85 because 2 minus 0.15, right? So basically what the reward returns calculation does is it actually takes the 2 here and then multiplies with the gamma factor. We will choose gamma factor as 0.99 so that every step gets a different reward. If I put 1 here, assume that gamma is 1, every step will get the same reward, which means next time when the agent is at the same state or different state, we will not be able to differentiate between multiple actions, and we will not be able to choose the correct action which will allow the agent to reach the goal and get the maximum number of reward. So basically what we are going to do is, once we get the 2 reward, maximum reward at the final or minimum reward in the final state, what we will do is we will multiply that reward with the gamma 0.9 in here, and then add the checkbox, clicking checkbox. So we will get 1.79. We will use this 1 point, which this will be the reward for step 3. You will use this 1.79 and multiply with the gamma and get the reward, modify it, we will get another thing. So here this will be reward for step 2. Similarly with the 1.57 might be the reward for step 1. So basically what we are saying is agent to the agent policy is, if we are starting with the 0.0000 state, we will get 1.57 as a reward if we click username. Okay, similarly we will have multiple different rewards, right? We can calculate which step gives an advantage, which step gives, if you click, this is a reward for clicking one username from this state, right? Yeah, assume there is another state one, and then like probably we are clicking, we are entering password, then the advantage might be 1.2, and initial state, when we just click the checkbox, the advantage might be 0.8. Basically what we are saying is, this are the 3 rewards, you choose what is the next best action. So initially the policy will always choose random things, and it won't even consider this, but moving on, every reward will be like almost equal, or like will be like normalized, and we will choose the best action. So these rewards will decide how much policy is confident in choosing a particular value, or in choosing a particular reward or particular action, right? So that's how we are going to calculate the reward. Based on the rewards function, we will reverse it, we will get the reverse reward, and then here initially the rewards function will look like, first step minus 0.5 minus 0.5 minus 0.5, and the end will be 2.0 because we completed, agent clicked the sign in button and attained the goal. So we are going to use this and then multiply the reward with the gamma and then add the reward. So this is how we are going to do this. And once we do that, we will get the end reward, and then we will send it to the caller. We will use it to calculate the advantage and ratio. There are 2 things, advantages and ratio, which will be used to calculate actor loss. Critics loss will be directly calculated from mean square error between the critic value. The critic will always emit one value. We will get this value and check. We will check the actual reward. The actual reward returned might be 2, right? And the critic might have said like, okay, this minus 5 might be the result. So basically we will calculate the mean square error between minus 5 and 2. I'm giving example, just I'm saying like minus 5 and 2, we will calculate mean square error. That will be the critic reward, and we will multiply in PPO policy, critic loss will be, PPO policy says always multiply critic loss with 0.5. So we will do that, and then we will add the actor loss as the whole network loss. Yeah, you can see here the loss is always 0.5 into critic loss. As we discussed, the critic loss will always be multiplied by 0.5 and then added with the actor loss, and this loss will be back propagated into the PPO network, and we will use a AdamW optimizer to train this PPO neural network, right? So critic loss is a MSE loss, that's what we saw. We didn't see actor loss yet. So to calculate actor loss, we need 2 things. One is a ratio and another is a advantage. So even after we calculate, we will come to ratio and advantage. For now, there are 2 terms, ratio and advantage. After we calculate the ratio and advantage multiplication, we don't want the PPO policy to learn very fast or too quick, so we will clip them. We will clip the whole actor loss between 80% to 120%, which means plus or minus 20 is what is allowed for the total loss. For total actor loss from the old value to new value, it cannot go below 80% or of the original value, old value, or 120% of the old value. That's why we are doing a clamp. So basically the actor loss will be either ratio into advantage or ratio into advantage clamped between the minus and plus 20%, which allows the PPO policy to avoid learning from lucky guesses. So basically, when this will happen, when the clamp will actually be needed is, the ratio might go like way upward, like whenever the critic says I am guessing 0.5, but the actual reward is probably 2.5 or something very big, which means the agent is really lucky. But also we want to push the whole policy towards a winning agent or winning steps that the agent follow, but we also don't want to like over optimize for that particular step only. Basically, we want to make sure we are learning slow always in PPO policy. So we will always clip the ratio to 80% to 120% of the old value at any point of time, and we will calculate the advantage. So what is the ratio? So if you remember, for every state, agent takes an action, and PPO policy uses the actor to give 4 distribution. In our cases, four probabilities, right? 4 log probabilities will be the output of any actor network, and a single value might be the output of any critic, right? So basically what we are going to do is, we will take the old probability, which will be always 0 0 0 at any point of starting point, and then we will once an agent takes an action, it will pass the input state and also the whole run the whole PPO policy and get the new probability, right? So whenever the agent takes the current state, it will return 2 things. According to PPO policy, it will return one distribution probability, log probability, and then critics reward expectation, right? So this will be this will be like 4 values, probability of log probability of each action in the action space. Here we have 4 action, most likely it will have 4 different values, right? Something like that. So basically what we are doing is, we will store the old probability, and once the agent takes a new probability, we will find the ratio between the old probability action and the value of the new probability. So basically assume that action taken by the actor is username or password. Action taken by the user is password, right? Then we will calculate the ratio will be old value of password is what is the old value of password is 0.25, right? Ratio equal to 0.2 divided by 0.25. The current new value of password is 0.2, old value is 0.25. Basically the ratio is 0.8, which means the agent learned not to take that action. Basically with the current state, the probability of choosing password went from 25% to 20%, which is not good, which means some other action is preferred over there. So currently the policy is learning that at this state. Earlier I thought 25% is the best, is the probability of getting success for password or chosen for password, but I am confident that password is not leading me to goal, so I am going to reduce the ratio. So that's what it means, right? That's what I actually taken the example values here. But if you can see here, if I assume that this is a new probability distribution that actor gave, and this was the old probability distribution before this action was performed. So now the log probability of the old value went from 0.25 to 0.2. So this is how ratio is calculated. So next thing what we want is advantage. Advantage is calculated with the total rewards. Total rewards is the same thing we computed return, so right, that is called rewards. Based on this function, we found that the total reward might be we will we will take final reward and then multiply the gamma and cumulative reward with the earlier set, so that every single step has a proper reward leading to this reward, right? So basically this is a reward array. So this is total reward. We will take the total reward array, and then for each step, step 1, step 2, step 1, step 2, step 3, step 4, for each step the critic also would have given a reward value. So on step 1 critic might have set like 0.5, step 2 critic might have set like 0.7, and step 3 it might have set like 1.6, and step 4 basically there is no critic reward because the action is complete. But you can see that we will, for every step taken, the critic will give you one value and actual value might be totally different. So the advantage is the difference between actual reward and the critic's value. So we are going to multiply this advantage under the ratio and then get the actor loss. We don't want the actor loss so to be like super big or super low, so we want to clamp it down to some part. We want to make sure the PPO policy is learning as small as possible. That is the reason we are clamping it down. We will find the smallest value of actor loss with either one of this and then take it as actor loss. And the critic loss is simple mean square error between the critic's value and the total reward. Almost similar to advantage, but this one is mean square error. And we will take 0.5. This is a PPO value, PPO algorithm. So we will take this actor loss and then multiply the critic loss with 0.5, add both the losses and back propagate to the whole network and then train the network. Here I am using optimizer as Adam, but since it's a simple network, Adam is more than enough with the learning rate 0.005 to stabilize the network. But Adam W also works, momentum also works, and SGD might be slightly slower, but Adam W and Adam are somewhat constant in this PPO policy networks. So till now what we have done is we defined the UIGEM. We also defined what are all the action spaces, what are all the states, and we also defined how the environment will react for each action taken by the agent. Now we also defined what is a PPO network and what are all the constituents of PPO network, like actor and critic. Now later that we are now looking at how we are going to train this PPO network. Okay, we will create the web UIGEM, whatever we did, initiated it, and also we will create the PPO and we will define the optimizer, and we will run this whole training loop for 100 times so that the training stabilizes and the agent really learns how to sign into a particular page. Correct. So basically that's what we are doing, and for each episode we are going to do this till the agent is clicking on the sign in button, either with the reward, positive reward or negative reward. So we will keep selecting an action till agent completes. We will keep selecting an action and we will sample it. So basically this is the most differentiating thing. If we don't give a probability sample, the agent, even if we do this exercise for 100 times, if we don't do random sample, what will happen is the agent might pick always the same state again and again and again, or it might pick only the higher probability states, which means every single agent 100 times will pick a username and there won't be any variety, which also means that agent and policy network will never learn. Only doing by random actions initially, agent will know what is a wrong step and which step leads to goal and which step will lead to a negative reward, and how to define number of steps. So basically, unless we sample the action from the existing action space, irrespective of a probability initially, we won't be able to make the environment to or the policy to learn, right? So we will take the action and we will make the environment to react to the action, and we will get the reward, and we will keep adding the states, new states and reward and values and log probabilities to the array, and then once the whole thing is done, our actor agent would have got either a negative reward or a positive reward, right? Which means it did attain the goal or it did not attain the goal. We will calculate the returns, we will calculate the advantage for PPO, We will come to GRPO. We will calculate for now for PPO, we will calculate the advantage, and we will calculate the reward. Right? We will calculate the loss, actor loss here. We will calculate the critic loss, and then we will back propagate the loss, right? And we will apply this policy. We don't need to apply the policy for every single time. The reason why the back propagation is happening for once in 5 times is, if we apply the whole policy every single time, it will be like way too many updates to the policy, which will lead to instability. So basically we want minimal updates, but also not very low number of updates. The update should make some sense. So basically that's the reason why we are collecting all the policy advantages and then running the back propagation once x number of steps. So basically we will do this for x number of steps. So that's all I think we have for PPO. Let's run this in the PPO mode. I'm not going to run this file exactly because there is no log. I'm going to run this file. Actually, I have both files have same code, but this one has better logging mechanism, so we can see what's happening. Currently, mode is PPO. We will run this. So once I start running this code, we'll see what happens. So you can see here, after I ran this PPO policy, initially on the left side graph, you can see initial reward is -2, and before 20th episode it became -1.5, which means the agent tried to sign in without filling any field. It sometimes made smaller mistakes, it sometimes made like very large mistakes, and at almost majority of the times it went and completed the task. The most important thing about PPO is in this graph, right? If you can see here, the PPO algorithm ran like randomly for first 25 times. It took like random steps, but once it starts maturing, the number of steps it took, it became like super low. You don't see not more than like 5 steps. On an average it took 5, even less than 5 steps. Sometimes it took randomly 10 steps, but you can see here after a huge spikes it almost stabilized around 30th run. So this means a PPO has already completed its study, and right now with this page it can confidently definitely complete the goal with minimum number of steps. Let me close this and then come here. You can see the logs. I ran this for 100 episodes. So basically the episode 0, the action taken, initially it said I will click the sign button. That's the first step it took randomly, and it got -0.5 as the reward. The second time when it ran, it took 0, filled the username. Third, and the second step, it again after filling the username, it tried to sign in button and it failed. Since earlier it was like it was 0.5, I think it became -1.5. Okay, I will go into reward calculation later, but you can see here it didn't succeed because it was filling only username and then clicking sign button. Here it just clicked remember me and then tried sign button. It didn't work. Next it filled the password first, and then filled the username. Now it is saying sign success, but I think it didn't check. Somewhere it didn't check for checkbox, but it's fine. So you can see it actually is learning even in one episode, saying that okay, something is wrong. So by just doing one action, I will not be able to get a better reward. So basically it is trying to get more rewards, right? So in the 10th episode to 20th episode, it tried to do password, username and then remember me, but it did not click sign in button. So next step, it didn't click the sign button. It again tried to fill username, and then it clicked sign button. Basically it took 7 steps instead of doing the completing it in the fourth step. That is the reason every time it got a minus 0.05 penalty. That's the reason why it actually when the reward went from 2 to 1.7. Basically it actually keep back propagating this reward and converting this reward into reward returns, this reward and basically cumulative reward, this reward into reward returns, and based on the reward returns it calculates the advantage and ratio and calculates the actor loss and critic loss, and back propagates loss into the actor network and critic network and on the hidden layer. Gradients and weights using RMW optimizer. So you can see here after some point you can keep seeing it started filling password, toggle remember me, fill user, and then click sign button. So basically at episode 90 the policy really learned that it just needs to do only these three actions in any order that to get the to maximize the reward. So basically for initial steps it did not understand what to do. Finally it understood, right? So now we have a with this we have a UI gym. UI gym is the place where AI agent can play. Right now this AI agent what we created can sign into any kind of login form, right? Basically any login form will have a username and password. So basically if I run this on a real website also, it can do this stuff. So learning epis progress is first 10 episode it took 1.21 as average reward. Last 10 episode it almost came close to 1.85. That's the best possible reward, right? So implement it actually improved really well, and initially it took 33 steps. So 7.4 is the maximum average step, but at a later point of the runs it started taking only 4 steps. It identified what are all the 4 steps it required to do to complete the goal within minimum number, getting maximum reward. So so these are really good. Let's move into GRPO. For GRPO I'm not going to change much. The one thing which I will change is the advantage, because in GRPO there is no critic. So the difference between GRPO and PPO is the PPO structure has a actor and a critic both, correct? But a GRPO that does not need a critic. So basically we can ignore the output of critic, and also we can ignore the back propagation for the critic. So without critic, how will algorithm know whether the output is correct or not? So for that GRPO proposes you spawn or create multiple browsers parallelly at single time, and like probably create 10 agents at same time. Make the 10 agents to do same task, even with randomness. Make the goal will be same, that is like a fill username, fill password, fill some checkbox, click the sign button. You can do it in any order. So all the agents goal will be to click the sign in button and complete the game, right? So basically GRPO says spawn multiple agents in parallel and compute and find what is the best possible agent which achieved the goal with the minimum number of steps, right? Find the best person out of X. So basically in this example I'm going to create 4 different agents, which means 4 browser, and the 4 agents are going to run the same algorithm or same steps or similar steps, same task. We are going to tell that agent that if you click sign in button and then if you have filled all those 3 fields, then you will get reward equal to 2, right? Your reward will be 2. Basically that is the goal for all the 4 agents at the same time parallelly running, trying to get a reward, competing with each other. And then finally what we will do, we will get the average of all the rewards. We will use the same reward computation, but we will get the average of all the rewards, and then find the difference between each reward with the average. Somewhat you can say this is equal to a variance kind of formula, standard deviation. How much is the actual reward, current reward is deviating from the average reward, and then subtract divided by the actual standard deviation. right? We will take that formula as the advantage. So basically we are removing critic. That's the first thing from PPO. Instead of critic, we are going to use mean. So we are taking all the reward. Once we get all the reward from 4 agents, we will compute the mean of all the rewards and subtract it from them. Once we subtract, we will divide it from the standard deviation. We will get the advantage. For the ratio, the actor is still there, so we are going to use the actor, because actor is the one who will choose the action. We need somebody to choose what is the next best action from the current state, so we are going to use the actor. The only difference is here in this example we are going to remove the critic because it is not PPO, and instead of using a critic as to calculate advantage, we are going to use the mean and standard deviation of the total rewards. Then next you can ask what will happen to the critic loss, because we have the loss will be critic loss and actor loss. In GRPO there is no critic loss, so basically actor loss will be the final loss. So that's a two difference which we are going to do GRPO and PPO, at least for this example. For complex examples you can do multiple other stuff, but for now I am going to use the same mode, same computation returns for both. Everything is good. There is no one way to do this, but the main idea is spawn multiple agents at the same time. How I am going to do this is, I am going to show you guys. These are all logging stuff, so that's the reason why I removed. It's more verbal, very difficult to understand at any point. So basically I am going to spawn, no, where is the spawning? Yeah, so here each batch size is 4, so we are going to spawn 4 different headless playwright, and we are going to get to 4 agents, and we are going to use 4 different environments or 4 copies of same environment, and then make the agent to work on that particular environment and give back the result, right? We will get the result is what states, what are all the states the agent moved from. Initially it will be 0 0 0 to some xyz 1 0 0 1 1 1, whatever it is, and also what are all the actions that each agent took, and what are all the log probabilities of the particular actor. If we have 4 different actors, assume that 4 different browsers are running at the same time, which means there will be 4 different actor in neural network, and we will use the same neural network to calculate the action, but because we have to calculate the loss and back propagate so that the network learns. So basically even though it is 4 different and learning in parallel, we will use the same network to calculate or compute the action, right? So basically this is what we are going to do. This is the main place where we are going to spawn 4 different playwright and each 4 different agent. The goal will be same, computation will be same, network which decides what is the next action will be same, but only difference is we are not going to run serially anymore, because we need some base, and the GRPO says you have to be the best among the peers, and the policy will be steered towards the best. Assume that the best policy takes only 4 steps. Best agent, the worst agent takes 25 steps. Basically GRPO will discard the worst agent and then steer all the agents from the next time to pick or to move towards the best agent which took 4 steps. So basically that's why we are taking the mean and then dividing by the standard deviation. Okay, so we will run this. There is not much difference between PPO and GRPO in terms of code, or at least for now whatever I have written, but in terms of actual actions there is like a lot. I hope I changed the training mode to GRPO. No, it is still training with PPO. Let it complete. Meanwhile I will identify the place where it gets switched. Yeah, mode is GRPO. GRPO needs parallel. Every agent will work in parallel on the same task in a different environment. the actor network will still be there, critic network will be discarded. You can still see here the PPO network learns after 30th episode, and then pretty much it takes 4 to 5 actions after that, which is good, which is very stable. PPO is very stable. That is really bad. The best thing about PPO is it is very stable. The worst thing about PPO is it is very stable. It brings too much of stability. No, which also means not much variety. We will run this again after changing to GRPO mode. Right now we are training this network in a GRPO node in 4 parallel browsers. You can see 4 parallel browser will be coming up, and I don't know why it is not showing here. Yes, you can see here 4 parallel agents are working, right? If you can see sharply, there is agent, and then it tries to click. So 4 browsers at the same time, it keeps doing this and calculating the overall reward, and based on that it is updating the actor network policy. I hope you guys are able to see multiple browsers getting, and then each agent is doing the same task of username, password, clicking the button, sign in button, sort of. So this will run for quite some time, close to 100 episodes, right? Meanwhile, we'll wait. This is looking good. Probably I should have added like a millisecond of pause, but even with this, running 100 episodes in my local GPU, it takes some time, at least like a couple of minutes. What will happen next time? So in next chapter, what we are going to do is, I'm going to prefer GRPO, but we'll also see small PPO. Next chapter, our UI gym will be completely a proper playwright based UI gym again. It will be a proper e-commerce website with all the clusters. Not this one is super small, like you can see like only 2 fields and a sign in button and like basic UI, right? So we will start working on cloned UIs. We will clone couple of e-commerce website UIs and then start working on GRPO and PPO. Same policy, same updates. Only thing is we will change the UI gem. Okay, and then we will train a e-commerce web agent using A100, because current, if you can see here, even this GRPO with 100 episodes and a smaller smaller HTML took close to 2 minutes, 1.5 to 2 minutes, right? But if I start running the same in local with Amazon e-commerce website, the agent will, even for with 100 episode, the agent will not learn much, just because the action space is way too much. Like currently action space is only 4. Assume if I start working the same agent in Amazon's website, where every single thing, every single page, the action space will be at least close to 300 to 1000, right? There will be at least 1000 clickable links, couple of 50 user inputs, checkbox, radio buttons. So the 100 episodes might not be like enough for an agent to learn, and even if it starts working on like one user button at every single point of time, consistently it will not be able to complete any flow, just because the action space is huge. So what we are going to do is I will try to push this into one or in parallel to 800 GPUs and see how GRPO performs and how we can actually substitute the same code. Not much difference in PPO policy or PPO update, network update. Only change is going to be in the size of the HTML and the number of actions possible. So that most of the times GRPO might lead to training instability. This is one of the known problem in the space, not only with the GRPO, most of the reinforcement learning, because of the negative rewards and the sheer number of actions possible in action space, and a lot of open questions that is usually being addressed without a closed space. The training instability leads to agent learning bad habits, and sometimes to and the other point is reward hacking. So two major problems which I usually notice is reward hacking and training instability. Reinforcement learning environments are mostly unstable because of, and also the rewards diminishing rewards and varying rewards to a large extent make the total training loop unstable. So that's a couple of things you need to take into account, especially for GRPO. The other problem with the GRPO is since it is a mean average of output from all the agents, if every single agent is doing going in the opposite direction, the mean reward will be 0. And also if every single agent is super random, the whole network might not converge at any point of time, right? So those are things which you need to take care of. So to fix that, you can spoon feed initial steps and then start GRPO. That's a possibility. There are few areas that can help. But for now, I ran the GRPO and you can see the difference between PPO and GRPO. In PPO, after 20th episode, the upcoming 40 to 100 were super clean and consistent. We had like multiple less than 5 episodes, but in GRPO, even though it was learning for a very long time, you can see 15 number of steps, 10, close to 15, close to 15, more than 10, more than 10. So GRPO is like this because of the design. But usually GRPO is used for reasoning purpose more than like doing this. And used in like open space rather than closed space. PPO is like far good in case if you want to do closed space issues, like if you see here there are only 4 possible actions, so action space is somewhat closed and controlled, the environment is not super open, and possible actions, possible states can be controlled, right? So in those cases PPO is more stable, it is more preferable. And you can see here even like even after learning for a long time, the reward actually went to minus 1.5, and here it had a negative reward in the 100th episode. So basically GRPO training is not as stable and preferred. It is preferred, it is good. DeepSeek actually popularized this more than anybody else, but it actually used that for reasoning, not for closed task agent training, right? So you can see the difference between PPO and GRPO. I hope this is, and we will read what happened. Right, we launching 4 parallel browsers every single time. Episode 0 to 3, agent 0 took minus 0.75 reward, and it took 20 steps to complete. Agent 1 was like awesome, it took 9 steps. So basically after this episode 0 to 3, the GRPO network will push all the agents towards this 9-step agent, saying this is the leader, this guy is the guy to follow for future. So identify from now on, identify the other things and then move the policy towards agent 1. So after the 4 to 7, again this guy is the leader for this pack. So basically we will pick good things from the leader. So what GRPO usually does is run multiple agents at the same time, find the leader, push the policy towards leader, because it assumes that leader is good, leader is doing some good steps, following some good disciplined rules. That is why it is getting reward, better reward than anybody else after attaining the goal. So basically that's what GRPO is. We are not the same network as PPO minus the critic. There is no critic, there is no judge. GRPO evaluates every single reward against its peers. Basically that's what schools does, and also interviews does, right? If you have a pool of candidate, you have to choose one out of them for giving a job across 6 months, because the goal is to close your requirement and get the best guy for that particular job. We cannot get the best guy in the world, but in the pool of candidates you can get the best guy and assume that that person will do the job, right? And we will push other hires to be looking like more like him. So that's our policy update. I think that's all I had, but before we wind up, I just wanted to recap on what we did. We are still on chapter 3, creating a basic UI gym, and we also did a PPO agent, we did a GRPO agent. We created a web UI gym with four inputs, and four input gave us four action space. Four possible actions available in this playwright based UI gym, and because of that we get state of four integers, and environment we reacted for each actions taken by the agent, and the PPO had input layer projected into latent space or hidden layer, and the hidden layer, from the hidden layer there are two different branches. One is called actor network and another is called critic network. Actor network will choose the action, best possible action, or give the log probability what it thinks should be the next action, and the critic will give what will be the reward from the current state, what will be the reward that the network will receive from the current state. This is a guess, it will generate a guess, and over a period of time the guess will look very close to the actual reward, and over a period of time actor will give you the action with the highest probability, which will lead to achieving the goal in minimum number of steps, if that is one of the goal. So for GRPO this network will be like nothing, and we will have only actor network. So we also saw how to compute the returns, and we also trained PPO network. This is a PPO network, and we used Atom Optimizer. We ran both the GRPO and PPO for 100 steps, and then one difference between PPO and GRPO is there is no critic in the GRPO, right? We use the mean as a critic, or to judge the current reward. We use the mean and the standard deviation of all the agents which was spawned at the same time. In the PPO there is a critic which will give you what it thinks at that point. Based on that we will calculate how much the critic is wrong. So basically the advantage will tell how much the critic was wrong. So we will calculate advantage in both of this stuff, and in the actor always gives a probability. We will take the new probability after the state change, and we will check, we will find how much the probability changed based on old probability. So we will store the old probability, and based on the new probability we will divide the new probability and old probability and see how much it has changed for that particular action, and then we will take that as a ratio, and then multiply how much the critic is wrong and get a loss. This is called actor loss, and we will calculate the MSE loss, mean square error loss, between the actual critic value, critic's guess, and the actual reward, and take that as a critic loss. So for PPO the loss will be actor loss plus 0.5 into critic loss. For GRPO, since there is no critic network, the actor loss will be the final loss. Once we get the loss, we will back propagate the whole loss into a neural network and then optimize the network, so that after period of time PPO will definitely stabilize to give a perfect, almost close to perfect kind of a agent, and GRPO will also become better, far better, but this one is, the usage of GRPO should be for reasoning more than close to task or agent training. In the chapter 4 next video, it's going to be serious session. Stay tuned. If you really loved the video, click the like button and also subscribe to my channel. Meet you in the chapter 4.